Hey guys, I'm just going to apologize in advance because I'm recording the first part of your all's notes like this morning, like Friday morning, and it's currently storming, so if you hear the thunder, just ignore it. But this is going to be, I guess, part 1 of 3 of the videos that you were going to watch for your 4-2 lesson. The sub should have given you guided notes, so if she didn't, tell her that you're supposed to have gotten notes. But I'm going to go through the first part of the 4-2, which is like examples 1 through 4. And once I get through 1 through 4, you're going to close out of this video, and then there's going to be 2 videos that say 4-2 day 2. Those are the videos that I recorded for first period and third period, but you're still going to watch them because they're still going to align with the rest of your guided notes. The example numbers will just be different, so don't be thrown off by that. Same problems. Okay. Well, let's get into it. So for this lesson, you guys are going to be learning about the remainder theorem and just polynomial division as a whole. Now, this first video, so the first part of your notes, is focused on the remainder theorem, whereas the other 2 videos, so like the bulk of your lesson, is going to be over actual polynomial division. Okay. So the division algorithm states if f of x and d of x are dividends, where d of x is the divisor, then there exist polynomials q of x and r of x, such that f of x divided by d of x, because remember, we've said before that fraction bars imply division, but f of x divided by d of x equals q of x plus r of x over d of x. Okay? And the quotient q of x is what is left over after dividing f of x by d of x, with r of x being the remainder. Also, if you will pause this video real quick. I don't know when my pencil's working. There it goes. But if you'll pause this video real quick, and at the top of your guided notes or on the side or somewhere, if you will write the division algorithm and then actually write this down, that would be awesome. But you can just pause it, but I'm going to keep going. So all this states is that if we have a dividend, which you're going to see this more in the next video, but if we have a dividend, which is just some function, okay, and we divide it by another polynomial, which would be considered our divisor, then the result of that division would be the quotient plus the remainder over the divisor. And you're going to see in the second video that this is just basically telling us how when we do polynomial division, this is how we will write our answer. So this is how we will write the result. So again, f of x, our dividend, divided by some polynomial divisor, d of x, is equal to the quotient plus the remainder over the divisor. And you can see down there at the bottom that the quotient q of x is what is left over after dividing f of x by d of x, with r of x being the remainder. You guys don't have to write this down. It is important, so make sure you hear it, but I'm not going to make you guys write it down. So, as far as defining factor goes, if the remainder when dividing f of x by d of x is 0, this is a big thing, and we'll come back to it a couple times in this video. We'll also come back to it in the next 2 videos, but if the remainder when dividing f of x by some polynomial d of x is 0, then we refer to d of x as a factor of f of x. If d of x is a linear expression, and remember, a linear expression is like x plus 4 or 2x minus 1. So you can see that our x is our only variable, okay? And we can have various coefficients, various constants, but that's what a linear expression is, so don't forget that, okay? But if d of x is a linear expression with the remainder being 0, then we say that d of x is a factor of f of x, but it also represents an x-intercept on the graph of f of x, okay? And it's important that we remember that x-intercept, root, zero, solution all refer to the same thing. Those are vocabulary words that we're going to hear a ton in this unit, so make sure that you understand that those all mean the same thing, okay? So this is where your little guided notes comes into play. So it says a polynomial function is graphed below. It says list all the factors, okay? Now again, we said factors represent x-intercepts on our graph. So the first thing that we're going to do is we're going to put a point at each x-intercept on our graph. And we're going to label them. So this would be x equals -5. This would be x equals -2. This would be x equals 4. And this would be x equals 6. Okay? Now, we're going to make a note up here that the x values and the binomials which I'm going to put expressions, because you're going to hear me say that in some of these examples. But the x values and the binomials, or the expressions, are opposites. Okay? They are opposites. Now, what that means is, since we're trying to list all the factors for this polynomial function, because that's what it asks for, we're going to start by listing the x-intercepts. So we have x equals -5, x equals -2, x equals 4, and x equals 6. So the binomial that would be represented for each of those would be the opposite. So if we have x equals -5, then the binomial is x plus 5. If we have x equals -2, binomial is x plus 2. X equals 4, binomial is x minus 4. X equals 6 would be x minus 6. So you can see the x-intercepts and the binomials are opposite of each other. And specifically, notice that these are all x values, okay? I did write x-intercepts here because that's what they were. That's what we were picking out. But this whole opposite thing is true for any x value on a graph, not just the x-intercepts, okay? Again, the reason why we're picking out the x-intercepts is because all of these binomials here are factors of f of x. And again, that's because they come from x-intercepts. Now, if you're asking yourself, okay, well, why is it the opposite? Well, if you imagine if we take, which I'm just going to write it over here, but imagine we take this x plus 5, our first binomial, and we set it equal to 0. That would be x equals -5. Same thing if we take that x minus 4, we set it equal to 0. We would get x equals 4. So the x value is the result of setting that binomial equal to 0, and that's why they're going to be the opposite, okay? Now, it says at the bottom, a linear expression is a factor if its remainder, or the y value, is 0. I want you to make a note that the remainder and the y value are the same, okay? We're going to use those interchangeably. That's going to be a tool and a fact that we're going to come back to a couple times over the next 4 examples. But a linear expression is a factor if its remainder or the y value is 0. And you can notice here that for this first one, that order pair is -5, 0. Since we have a y value or a remainder of 0, that means that x plus 5 is a factor, okay? And you can see that over there with the binomials, we said that those are factors, okay? Now, just for fun, and I'm going to do this in a different color, let's pick out another point on our graph. So I'm going to do, let's do this one. So this point is 7, 3, okay? The x value would be x equals 7, okay? The linear expression, or the binomial that would represent that, would be x minus 7. Now, 3 is our remainder, because again, the remainder and the y value are the same. So we can see, even though x equals 7, which in turn is x minus 7, exists on our graph, the remainder is 3, so x minus 7 would not be a factor. Okay, so it is not a factor. And all that tells us, which you're going to see actual polynomial division in the second two videos, but if we were to take whatever this function is, I don't know what it is because it doesn't tell us the function, it just tells us it's this graph. But if we were to take that function and divide it by this x minus 7 here, we would get a remainder of 3. Okay, and again, that's going to tie into the next two videos, but I just want to point that out, that it still exists on our graph. It's still a point. It's still a binomial, but it would not be a factor because, again, factors come from x-intercepts. They have to have a remainder of 0. Again, you don't have to write this down. I'm just going to read it. So, the remainder theorem, which is what we've been building towards, states that when dividing a polynomial f of x by a linear divisor x minus a, so you can see x minus a, the x value would be the opposite, so x equals a. The remainder is f of a. So you can see here that a is the input, and this whole thing would be the output. So again, we have input, x values, input expressions, divisors, whatever you want to call it. And then the output would be the y value that we get, which would be our remainder. If the remainder, when f of x is divided by x minus a, so again, x equals a, is a 0, then x minus a is a factor of the polynomial, and f of a equals 0 represents a root of the graph. So you can see this is function notation. We talked about that a good handful of times in this class, and we're going to see it again in this part of the lesson. But this would be x comma y, so a comma 0. And you can see that if you get a remainder of 0, then x minus a is a factor, and a comma 0 represents a root of the graph. And remember, root and x-intercept mean the exact same thing, okay? If the remainder, when f of x is divided by x minus a, is not 0, then x minus a is not a factor, and f of a equals some number, so that would be a comma just some number, okay, be any number, represents a point on the graph of f of x, but specifically not an x-intercept. So going back to our graph that we just looked at, we can see that -5, 0, -2, 0, 4, 0, and 6, 0 are all roots or x-intercepts on our graph, which means the binomials that represent those x-intercepts or those x values would be factors. Whereas up here, we had this x equals 7, which had a y value or a remainder of 3, so it still represents a point on our graph, but it's just not specifically a factor. Going back to the notes, it says use the graph to fill in the blanks, okay? So we've got 3 bullet points here. The first one says the remainder of f of x divided by x plus 5 is blank, okay? So the first thing that we're going to do is we are going to take the opposite, and we're going to look at x equals -5. Now, technically what we're looking for is a point on our graph where it has an x value of -5. If you can pick that out easily, great, but if you struggle to pick out points, trace over the vertical line that represents x equals -5, okay? And you are going to put a point where that vertical line and your graph intersect, okay? So that is the point -5, 0. So the remainder, when f of x is divided by x plus 5, is 0, because again, y value is our remainder. Now, we're going to make a little note that since the remainder is 0, x plus 5 is a factor. Okay, continuing on. I'm going to change the color. But the second bullet point says the remainder of f of x divided by x plus 6 is blank. Again, we're going to take the opposite. So x equals negative 6. X equals negative 6 is, again, this vertical line here. They intersect at this point. That would be negative 6, 5. So the remainder is the y value, so 5, which means that x plus 6 is not a factor of this function. Okay, last one says the remainder of f of x divided by x minus 7 is blank. Again, we're going to take the opposite, so x equals 7. That is this vertical line here. So that point is 7, 3. The remainder is 3, which means x minus 7 is not a factor. Because again, the remainder has to be 0 for it to be a factor. Okay, continuing on. Remember, you can pause the video at any time. I'm just going to keep going because I'm trying to get this video done this morning. But example 1 says the graph of f of x is shown. Which statements appear to be true? Now, if you notice, all of them say the remainder of f of x divided by some divisor equals 0. Okay, so for each of these answer choices, we are going to first ask ourselves, what x value is represented by that divisor? Now, looking at the other ones here, you can probably imagine that we're going to take the opposite of each one, and that is true. But for that first one, we have a standalone x. I want you to make a note here that if you have a standalone x, because we're going to come back to this, I think, in example 4, but you would put x equals 0. Okay, so a standalone x is x equals 0. So x equals 0. Oh, just kidding. Hold on. Backing up. Sorry. So that would be our x value. The remainder is our y value. So this here represents a order pair of 0, 0. So what we're going to do is we're going to put a point at 0, 0. And we are going to ask ourselves, is that point on our graph? If it is, it's a true statement. If it's not, it is a false statement. Okay, so that one's true. Let's do another one. Second one says the remainder of f of x over x minus 4 equals 0. Again, take the opposite, so it's going to be x equals 4. Y value is 0. So this is a point of 4, 0. So 4, 0 is here. You can see that is not on our graph. Okay, so we are not going to check it. Next one. Remainder of f of x divided by x plus 3 equals 6. So we're going to take the opposite, so it's going to be x equals negative 3. Again, this is our y value, so we have negative 3, 6. Negative 3, 6 is here. That is on our graph, so this one is a true statement. For the fourth one, again, we're going to take the opposite, so it's going to be x equals negative 1. The order pair is negative 1, negative 1, which is here. That is not on our graph, so it is not a true statement. Lastly, again, take the opposite, so that's the x value. Y value is that negative 1, so we're looking at 1, negative 1. That is here. That's on our graph. It's a true statement. Again, pause if you need to. I'm going to go ahead and move to example 2. For example 2, it says the graph of f of x is given where f of 1 equals negative 5. Which expressions have a remainder equal to f of 1? Okay, now, looking at our answer choices, they're all f of x divided by some divisor, and then it gives us our graph. Now, The first thing that we're going to do, and you're going to see us do this in example 3 and 4 as well here in a moment, not 4, just example 3, my bad. But we're going to dissect or analyze this little function notation, okay? We know that that represents a point of 1, -5, because x, y. But what we need to recognize is that our remainder is that -5 specifically, okay? Because it says, which expressions have a remainder equal to f of 1, okay? Because that's what this wants to know. So, if it's given us all these f of x divided by some divisor, we're going to first take the opposite of each of those to get those x values. Okay, so we've taken the opposite for each of them. And then basically what we're going to do is we're going to put a point on our graph at 2, -1, -8, -6, and 3, and we're going to see what their y values are and compare it to this -5 here. Okay, so let's go ahead and do that. Again, I'm going to do these in different colors just so you can see it better. So 2 is this vertical line here. You can see we've got a point at 2, -5. So the remainder would be -5, because that's again the y value. That matches our given function notation. So that means we are going to select that one. Okay. Doing the same thing. -1 would be here. We've got a point at -1, 0. That means the remainder would be 0. And even though that means x plus 1 is a factor, it's still not equal to what was given to us in our problem. So we're not going to check it. Same thing with -8. That would be right here. We've got -8, 0. Okay, we've got -8, 0. So the remainder would be 0. Which again means that x plus a is a factor, but again it is not equal to the remainder that we're given, so we're not going to check it. We've got -6, which is here. That point is -6, -5, which means the remainder is -5. That does match our given remainder or given function notation, so we are going to check that one. And then lastly, we have x equals 3. That would be here. You can see that is 3, 0. So the remainder would be 0. So we're not going to check it. But I do want you to make a little note that that means that x plus 1, which I'm going to write factors first. But that means x plus 1, x plus 8, and then x minus 3 would be factors because we see that they have a remainder of 0. Again, pause if you need to. So for example 3, it says for a polynomial g of x, g of -9 equals 20. It says which statement must be true, okay? Now, before we even get into the answer choices, we are going to look at the function notation because kids always get tripped up by these types of problems, and I think it's because they read the answers and they get overwhelmed by it, or they're like, well, I know what some of these words mean, but I don't know how to figure out what's true. Start with your function notation, okay? So we've got g of -9 equals 20. I'm going to write this out to the side so I have more room to write. We know that this is an order pair of -9, 20. So that means we have an x value of -9, which means the binomial that we are looking at is the opposite, so x plus 9. And we know that 20 is our y value, but also we know now that that is our remainder, okay? Based on that, and I'm going to write this down here below. Based on that, we can say that x plus 9 is not a factor because the remainder is 20. And in parentheses, I'm going to put not 0 because that's the big thing, because it has to be 0 for it to be a factor. If it's literally anything else, it's not a factor, okay? So x plus 9 is not a factor because the remainder is 20, not 0. Now, looking at our answer choices, we're going to eliminate anything that has, or should I say doesn't have, an x plus 9. So if you look at answer choice A, it has x minus 9, and C also has x minus 9. So we're going to eliminate those because our given information is about x plus 9. So we know nothing about the binomial x minus 9. So we're going to eliminate those. Now, looking at the other two answer choices, we can see that answer choice B would be false because it says it must be a factor. And we said it's not a factor because the remainder is 20, not 0. So D would be the correct one. And D reads, the quotient of g of x and x plus 9 has a remainder of 20. Okay, let's go ahead and look at example 4. Now, you guys are just going to have to try this on your calculator. I do have the calculator app on my iPad, but it is not even remotely similar to your all's calculator. So I'm going to list the steps, okay? I'm going to list the steps. I think you guys can do it. You can help each other if you are confused. But let's read example 4. Says, which expressions are factors of the polynomial p of x equals x to the 4th minus 4x cubed plus 7x squared minus 16x plus 12, okay? And we've got 5 different expressions, okay? So, the first thing that you're going to do, and you're going to do this on your calculator, reset it if you haven't, but you are going to, I'm trying to remember the steps specifically, but you're going to click your y equals button, and then you are going to put this expression, so I'm going to put exp, into y1. And again, if you need to pause this as you're doing it, go ahead, but you're going to put the expression into y1, okay? Then you are going to click trace. Then you're going to type each x value and click enter. And the y value that it gives you is the remainder. Okay. So again, on your calculator, you're going to click your y equals button. You're going to put the expression into y1. Okay. Then you're going to click trace. And you are going to type each x value and click enter. And the y value that it gives you is the remainder. Now, for each of these expressions, we do have to list the x values. So we have -2, 1, 4. We said in, I believe, example 1, example 1, that standalone x was 0, and then 3, okay? So on our calculator, which I'm going to try to do it on my phone so that way I can at least get the answers for you to compare your work to. But on your calculator, you're going to type the expression into y1. Give me a second. Okay. And then I think on mine I have to do something different, so. But if you click trace and you type -2, enter, the y value that you get should be 120, okay? That is your remainder. Again, it is asking for the factors, which means it wants to know which of these have a remainder of 0. Same thing, if you click 1, enter, you should get a y value of 0, which means our remainder is 0, so we're going to check x minus 1. If you type 4, enter, you should get 60, which again means it's not a factor. If you type 0, enter, you should get 12. So we're not going to check that one. And then lastly, if you type 3, enter, you should get a y value of 0. So since our remainder would be 0, x minus 3 is also a factor. But that is it for this video. If you will go watch the other two, again, just remember that even though it's the day 2 lesson and it's going to say day 2, it is the correct one, okay? All the problems and everything will be the same as what's in your notes. Literally, the only thing that's different is the example numbers. But just shoot me an email or a remind message if you got questions.